Right, so I wanted to make a video talking about the process of creating a nav mesh for Magicka with the map maker. So first let's launch the map, and I want to showcase what happens without any nav mesh. So I added to the level a small goblin spawn, right? And when they come down, the guy taunts us and does just the same things he always does. But he stays in there because there's no nav mesh right now. He doesn't know how to move to us. If we get close to him though, there's a small degree of movement that can be performed by the goblin without the need for a nav mesh. For example, moving away each time they do so, they appear to do so without using a nav mesh, and each time they launch towards you or walk, if you're in range of them, well, they seem to be capable of doing some of those movements, especially in open areas. As you can see here, he's having not that much trouble following me. But the moment we get close to the crates, things get a little bit bad. And if we move too far away from him, he just doesn't know what to do anymore, right? So that's the problem of not having a nav mesh, because inherently the AI in this game, as much as there are some of the capabilities that it has that can be performed without a nav mesh, most of the movement really depends on being able to navigate the environment through the nav mesh, right? Okay, and now I'm gonna show the map using a nav mesh. Okay, so let's load it right up. I modified the level to make use of a nav mesh, and well, I forgot to include the base folder, so there's no textures, but as you can see, the goblin clearly is following us, and he is doing a pretty good job. And he's actually respecting collisions and walls. The path is kind of tight for him to go through there, but if we go through this other area, he might do a better job of following us. Yeah, not bad, not bad. Could be improved, but he's clearly capable of navigating the environment now, unlike before. So that's, well, pretty good. Yeah, no, not bad, not bad. He's doing quite nicely. So obviously there's lots to be improved in here. Also, let's just go out of this area where there's no longer a nav mesh in here, and you can see that he's no longer going to be capable of following us properly. We might be able to lure him out of bounds if he leaps at us like a jockey with this little jump he does from time to time, but once he's out, he won't be able to properly pathfind to us. So in here, there's no longer a nav mesh. Like this line I'm drawing with my cursor is where I stop, and he's basically broken and is trying to retreat back to the nav mesh. So yeah, he does navigate quite nicely if we stay in bounds of the area that I mapped out. I made quite a few tests actually trying to get this to work properly, and it's pretty insane. I've got lots of things to explain regarding how the nav meshes work. So if we go over 1 second to the Blender quote-unquote level editor, okay, I'm gonna save this real fast. This thing right here is the level, and this mesh right here is the nav mesh. Now this is pretty weird looking if I open it, right? I mean, obviously what is going on here is that we're tracing around the geometry of the level, right? And we're placing vertices in here and then joining together the faces. We don't care if they are triangles or not, because even though the pathfinding algorithm under the hood only uses triangles, my exporter addon takes care of triangulating the mesh for you, so you can be as sloppy as you want with the geometry, as long as, you know, the faces are not overlapping each other. Like something like this, for example, would be terribly bad and would be broken, but this is okay. Now I'm going to open another file first, which is map 3. Now at first I thought that the vertices were like nodes, you know, and that every single node would be like a pathfinding point that the AI would be capable of using to say, hey, I'm gonna traverse to this location, right? So for example, I thought that if you were somewhere around here and the AI was here, it would take the cost of every single node between them, right? And it would make something like A star or whatever, right? But the AI using this nav mesh right here would get stuck. Why would it get stuck? I'm not entirely sure, but it has to do probably with the fact that this is too dense of a nav mesh, and it's probably taking ages for the AI to make the calculations required for it, right? And maybe the AI doesn't exactly use A star in the way that we think it does. For instance, if we open up, because this is actually something really good, the fact that we've got a reference, the developers of Magicka actually left behind a few FBX files in the versus folder, right? And this is the versus boat map, and it contains a nav mesh which I just moved out of the way, right? And here we can extract a lot of information about how things work in Magicka. And if we go over to this editable mesh right here, which is the nav plane as it is called in the outline, we can open it up and we can clearly see that all of the vertices exist only on the edges, right? Only at the edges. There's no vertices in the inside of the mesh, which means that the triangulation process and the creation of those edges and connections is actually what generates the whole pathfinding stuff, and the individual points are not necessarily nodes in the same way that they would be in a regular pathfinding algorithm, like something like BFS or maybe UCS or A star or whatever, right? There's lots of search algorithms based on nodes, and this I don't know the exact implementation, I haven't checked yet, but it's probably something like that. The thing is that it doesn't exactly work in the way that one would intuitively think. It's actually kind of similar to the way that nav meshes are generated in Unreal if you look at the way that they are created. So let me go over this file right here, okay? Or maybe I shouldn't open this file. Maybe it would be better if I opened this other file. Okay, there we go. So this is a decompiled example from the base game. This is the Wizard Castle level, right? And this right here is, well, the JSON I generated with Magicka Pub, and this right here contains the vertices, right? Which are basically all of the points that we've drawn out in the nav mesh, right? And these triangles right here, they have a collection with the 3 vertices that compose them. And these are the indices within this quote-unquote vertex buffer. It's not exactly a vertex buffer because it is like a vertex buffer, right? But it only contains positions. So yeah, that's what it is basically. And we just contain the indices of the vertices that we're pointing to for this triangle right here. So this triangle is formed with the vertices 0, 1, 2, okay? And if we look at this right here, it's got a bunch of neighbor data that we will be looking at in a while because it takes some time to explain. And it has a cost to go from A to B to C, and to C to A. So clearly when you read this thing right here, you think that these vertices right here are basically nodes in the search algorithm, right? So clearly there has to be something where you would interpret that the bots would probably pathfind going through the vertices, right? Like they would treat it more like the old nav mesh generation from Unreal Engine 2, where you would place the tiny apples on the map and that would help generating the nav mesh, right? So those vertices that would be on the middle, you would interpret and think, yeah, these are the nodes that the AI has to pathfind through, and say, yeah, I'm gonna go from here to here to here and to here to get to the player, right? Because if we triangulate this, we've got diagonals. And at first, the AI would sort of follow you like that, then go in the diagonals, but if you got too far away, it would get stuck. And too far away isn't really even that far. Like if the bot is here and you stand here, it no longer follows you. So what's happening probably under the hood is that the search algorithm has some kind of depth limit, but rather than returning the closest position, right, it just doesn't return any nodes. It might return null, saying I didn't find the answer I'm looking for, right? And that's bad, obviously. That's a really bad thing, because it means that the AI is going to get stuck if it gets too far away from you in a densely populated nav mesh, right? So judging by the way that this is constructed right here and the way that it behaves in game with what we just seen, it's clear that the way that Magicka is set up, it's far better to generate a nav mesh where you place vertices around the objects, like you surround them, and that way these lines that we see right here, or better said, all of the lines that we see after triangulation, would be the possible paths that the bot can take between these locations, right? Now, obviously you would ask yourself, then how is the bot capable of reaching me inside of these triangles? There's no points in here, right? And that, first of all, is probably that when it gets close to you, it just uses this path to more or less trace where it has to go to reach you, and once it's close to you, it actually follows you closely. But apart from that, we have to go back here, and this is where we need to explain the neighbor logic. Okay, so I'm gonna bring in some notes that I've made on paper when I was trying to figure out what the neighbors were before I could even begin implementing the exporter logic, right? So basically, if you look at the example of the wizard castle right here, okay, we've got the triangles that are saying that we've got a structure that goes like this. We have, for example, some vertex right here, another vertex right here, and another one right here. And this is our first triangle in the nav mesh, right? And this triangle right here, okay, it goes like this. We have a vertex A, vertex B, and a vertex C within this triangle. And this one right here, for example, has index 0, this one has index 1, and this one has index 2 within the entire nav mesh, right? And we have computed the costs for going from A to B, from B to C, and from C to A, right? Okay. And this one right here would be our first triangle, which we're going to name T0 because it has index 0 within the triangle mesh, right? And then if we get another vertex and we locate it around here and we create another triangle, right? And you can verify this by looking at the output of the JSON file. We will have another triangle right here, which we could, for example, order like this. It doesn't matter what the order is, to be honest. We got A, B, and C, for example, right? And for A, B, C in this example, this one right here is going to be still vertex index number 1, this one is going to be vertex index number 2, and this one is going to be number 3, right? So this is 0, 1, 2, and 3. And this would be triangle number 1. And now, what are the neighbor properties? Well, the properties that say neighbor basically refer to the neighbor. When we got the neighbor A, what it's referring to the neighbor that is located on the edge that goes from A to B. So basically for triangle 0, the neighbor that goes from A to B, aka the triangle that should be located here, doesn't exist. There is no triangle in this mesh located in there, right? So the property that these neighbor values take when there is no triangle within Magicka's game code is actually the maximum value you can have in an unsigned 16-bit variable, which is, you know, whoops, 6, 5, 5, 3, 5. There we go. So that one right there, if I have put it correctly, it should be the max value. 6, 5, 5, 3, 5. Yeah. So anyways, that basically is used as a token value of sorts to refer to null, even though it's not the usual value. It's like saying that -1 means invalid, when -1 for an integer would technically be the max value, right? So for an int 16, the max value would be, the null value would probably be -1, and when you reinterpret that as unsigned, it's basically in 2's complement the exact same value as 65535, right? So I don't know internally what logic it has, but the reader code within Magicka uses unsigned during reading, right? So maybe when writing, it writes as an unsigned casted, like with type pruning, but the coders may have written -1 when they were making the maps. The point is that this right here tells us that there's no neighbor on this edge right here that goes from A to B. Now neighbor B tells us the neighbor that goes from B to C, and neighbor C tells us the one that goes from C to A, right? The names is pretty bad, but that's what it's named within the code. So in this case, the neighbor that goes from B to C is index number 1. So in this case, for triangle 0, so we've got T0 dot neighbor B is equals to 1, because this is the index of this triangle right here, okay? And if we look at the triangle number 1, if we go to T1 dot and we look at the neighbor that we go from A to B, for example, right? So that would be neighbor A, it would be 0, right? So in here we've got no neighbor, no neighbor, no neighbor, and no neighbor. This is a very simple nav mesh formed only by 4 vertices and 2 triangles, which is a really simple example that would only exist in a square room, but it's okay, right? So basically this right here tells us what the neighbors are for each edge, right? And this was actually kind of tricky to come up with an optimized way to obtain this information and export it in Blender, because there's not really much good documentation for Blender's API, and I eventually figured it out, and I thought this would not really be that useful. You could technically mark everything as this value and it would still work, but it is pretty useful because that's where the logic comes from, where it actually allows the AI to navigate through the center of these faces, right? Because once it's navigating within a triangle, these nodes right here are the points where it's going to be performing the main algorithm on, right? These are the nodes, quote unquote. But when it has to traverse through faces, it's probably using those values to know what neighboring triangles there are to traverse from one triangle to another properly. So it's kind of weird, feels kind of counterintuitive that having more nodes would break the AI. But yeah, basically when you want to make a nav mesh, you just surround the outlines of your shapes, close the faces, and that's it. Now this mesh I made by hand and joining faces, and it's very sloppy and it works just fine. But you could, for example, if we open up the map again, right, we can just get rid of this and we can create a plane that would be our nav mesh, right? And if we go over and put it at 0, and we can just lower its height a little bit, so it's more or less in a location where it can be accessed by the AI, we can just scale this up, just go like this, and we could potentially begin by doing something like this. So we add a cube and we just start cutting off stuff. So we can say, okay, we got this cube right here, I want to cut out this cube shape here and make it a little bit bigger. So we just go over and say, okay, make a boolean, right? And we make a boolean with this object right here, and we apply, and that's it. You got yourself your first cut, and it automatically does those shapes. So that's a very simple way to do everything without really having to join vertices by hand. Another way would be to just get rid of the faces and only have a vertex, right? You collapse everything and you start going with the outline like this, right? And you just more or less eyeball it, and after you're done marking out outlines, you would have to start joining faces in a very rough way, but at least one where you make sure that there's no overlapping triangles, right? So that you don't break anything. So those are the two quick and dirty workflows where you can get a nav mesh going really quickly in no time at all. I don't really like it. I probably make something that automatically generates nav meshes, but as you can see, even within the official FBX files, the mesh itself is here, and I don't know if this was made by hand or not, but this is such a simple mesh that it potentially could have been modeled by hand by the creators of Magicka. So in any case, it doesn't really matter, because as of now, if we open up this file and we look at the untitled JSON file where we've got all of the data that I made, if it loads, because it's quite a heavy file actually. Okay, let me move it to this screen. So we got our nav meshes in here, and the vertex locations are calculated automatically. Obviously, that's pretty trivial. But if my computer doesn't explode trying to read this giant file with millions of lines, we could see that even the weights and costs are calculated automatically, right? Like these costs right here clearly point to some space state search algorithm being used under the hood. Not sure which one, but most likely some modified version of A star, right? And as you can see, we got those two vertices right here, sorry, those two edges right here saying that there's no adjacent faces for this triangle, so this is probably a corner in the map, right? And this is probably an edge in the nav mesh, right? And anything that has neighbors everywhere is inside of the nav mesh. So yeah, and the costs are calculated automatically. The properties property determines what kind of nav mesh this is. Like to be honest, in the base game, it seems like every single one uses the default property, which is value 0. So if we go over here, the properties that we have is an enum that has different values, which are default, water, jump, fly, dynamic, and all. Not sure what all of these could be used for exactly in the future, but maybe you can mark a water area as water, where if it's frozen, the AI is allowed to walk on top of it, but if it's water, they start trying to avoid it. I don't know. I'm not sure how the engine handles all of this information under the hood, but for now everything is marked as default, so that the bots won't really have any trouble walking on regular length. We'll figure out all of this stuff over time. Potentially I would have to allow users to mark these properties per triangle, but yeah, it's all there is to it. It's working pretty nicely, and yeah, I mean, there's not much else for me to showcase.